Hold on. Okay. Each mapping diagram represents a relation. Determine the domain and range, and if the relation is a function. So notice the -1 has two arrows coming out of it, 1 to 0 and 1 to 3. So I'll circle this. So it is not a function. -1 has two different outputs. So no, not a function. -1 has two different outputs. Domain, I love these. -2, -1, 1, 2. Range, -2, 0, 2, 3, and 6. All right, then scroll down to number 4 when you're ready. Is number 4 a function? Does it pass the vertical line test? Yes. Okay, now this I think personally is probably the hardest domain and range to do because it's array. So let's zoom in and go slowly. My very leftmost point is here and it's open, so I'm going to put a like obnoxiously large open circle here and put my arrow going forever that way. So domain is x is greater than, and don't put the or equal to because it's open. So greater than -6. Okay, and then the range, this is the bottom, open circle down here again, and it's going to go up forever. So y is greater than -4, and it's greater than because my arrow is going up. Any questions about number 2 or number 4? Okay, now we're going to use a resource page in here today. It's not the whole lesson like it was on Friday, but if you could find the one that has 2-11 at the top. So the 2.1.2 resource page. And then just scooch this off to the side and set this up. Okay, so number 11 is a review from last Friday where we had the tile patterns and we were figuring out the equation. Let's read the problem. It says the table below represents a tile pattern. Make a graph that represents this tile pattern on the 2.1.2 resource page. Should the points be connected? We talked about this one time before today. So we're going to graph these coordinates on this table, but should we connect them? I see a lot of yeses and a lot of nos. Okay, let me ask you this. Can you have a figure number 1.5? Can you have a figure number 0.2? No. So do not connect the points. Okay, so we're going to write this, but first come over here. Okay, so 0, 2 is right there. 1, 7. 2, 12. 3, 17. 4, 22. Okay, so once you get your dots, scooch back over here. Figure numbers can't be fractions or decimals, so don't connect the dots for a tile pattern. Okay, but then we're going to break our own rules in number 12. So just hold on. So next thing we want to do is find the equation. And we can find it from the table or the graph. But to remind you, it's y equals growth times x plus figure 0. Y equals growth times x plus figure 0. Okay, what is the growth in my pattern here? How much is it going up by? 5. And how many tiles are in figure 0? 2. My equation is y equals 5x plus 2. And that's kind of what we did all day Friday. It was a lot more than that. We shaded like tiles and stuff and plugged numbers into the equation, voila, but all of that. Okay, so now you're sort of caught up for where we are at. Okay, so number 12 says if we violate our rules, so if we connect them, is it a function? If we connect the dots, is it a function? Okay, so go back to your resource page, connect the dots illegally. Is this a function? Yes. Why? Yes. Well, okay, it's linear. I understand what you're saying, but that's not why it's a function. I mean, it is kinda. Other than the vertical line, that's the only one that's not a function. But what do we do to tell if a graph is a function or not? Vertical line test. Yeah, okay. So okay, and why do we care? Why is that even a thing? We already figured out the equation. We already graphed the dots. We figured out the growth. But the reason that it matters is because now we can write it like this in function notation. So fancy notation with f of x. We can only do that because it's a function. Over here, I want you to just put yourself a very important reminder that y and f of x are equivalent as long as the thing is a function. All the way through math for the rest of your life, sometimes they're going to say y, sometimes they're going to say f of x. You just need to know that they're the same thing. Don't freak out. If you don't like f of x, just put a y there. If you don't like y, put an f of x there. All your life, forever, forever from this moment on, those two things are going to be interchangeable. Okay, draw number 13. So here's my next question. Before this, in CPM, have you heard of what's called the multiple representations web? Is that those words sound familiar at all? No? Okay, what it means is if you're given a graph, can you find the table and equation? Or given the equation, can you find the table and graph? Or given the wait, what's the other one I didn't say? Table, can you find the equation and graph? So it means like given one of the things, can you find the other stuff? So that's what we're working on right now in number 13. So in number 13, you're given a graph and it wants you to find the table and equation. Okay, so what is this coordinate right here? Nope. 0, 3. And what is this coordinate right here? 1, 5. Okay, so how much is it going up by? 2. Okay, so even though it goes off the paper or off the graph, what should the next coordinate be? 2, 7, and then 3, 9. Beautiful. Okay, now it says, okay, so you have the graph, you found the table. Now we find the equation, y equals growth x plus figure 0. Okay. Now I've spiced it up a little. All right, last one. What is this coordinate right here? 0, 9. Okay, now this is called a slope triangle, and I'm going to start using the word slope instead of growth after this. This is telling you that every time you go over 1, you're going to go up 12. So that means every time your x goes up 1, your y is going to go up 12. So x goes up 1, y goes up 12. Okay, so x goes up 1, y goes up 12, which is 21, right? Right? Okay, x goes up 1, y goes up 12. X goes up 1, y goes up 12. Okay, what is the equation? Y equals 12x plus 9. Look at you learning. Okay, so now we're done with the notebook. Once you get this situated, scooch the notebook to the side, grab the resource page again. How much slope stuff do they do in middle school? Do you already do all of this? So this is all review? I don't know. I should go ask them. I should go ask Mr. Medalla what he does. Then I could see him and we could talk about Costco. Okay. We both love Costco. All right, so number 14. So we're gonna say slope. And here's a new thing for you. The letter for slope is M, and I think the M stands for movement or motion. That's the only thing I could think of. And this is saying my line is going to go up 27 for every 3 it goes over. So the y is going to go up 27, and the x is going to go up 3. So it goes up 27 tiles for every 3 figure numbers. So how many tiles per figure number? 9. That was really it. Okay, now for number 15, we're going to start to make a formula out of it. So these guys, this triangle, this is called delta. And delta means change in. So we're going to say slope equals m. And you might have heard this before. Slope is rise over run, which is the change in y over the change in x. Okay, now what is that going to be in this problem? What is the change in y on this problem? 2. And the change in x is 4. And then you reduce it to 1/2. All right, we're already to the last problem, believe it or not. Okay, we're going to do 3 slopes for this problem. We're going to start with triangle A, which is down here. It's the biggest one. So look at triangle A. What is the rise? 6. What is the run? 4. Okay, and what does 6 over 4 reduce to? 3 over 2. Okay, now look at the little triangle B. What is the rise? What is the run? 2. That can't be reduced. That's it. That's done. Then they sent us a spicy one. reason why I have to be. Four point five. Okay, because 4.5 divided by 3. So you guys notice that this is 1.5 and this is 1.5. So how do I make this 1.5? Make it 4.5. And you can kind of count the boxes. You can kind of see that they're 4.5. Okay, the point of this problem is to show you that it doesn't matter where you put your triangle, as long as you reduce, you're going to get the same answer every single time. Because it's a line and they increase the same each time. Okay, now next thing I need you to do. First of all, look at the stamp sheet so you can see what the homework is. Everybody take a look at the stamp sheet side. '18 through 22, make sure that you have through 22. Okay, now this is what I need you to do real quick. I need you to open your packet to these 2 pages. They should be done. Leave it like that, open like this. Okay, then you're going to put your notebook with problems 6 through 10 open because that was the homework from the weekend. And then when I walk over to you, I'm going to look at this, look at your homework, and then you're going to flip it closed so I can stamp it. Does that make sense? Okay. And then as soon as I'm done with your table, then work on problems 18 through 22.